Okay, good afternoon and welcome everybody. I'm Alistair Pym, the Vice President for Innovation and Partnerships at NECC, and we're delighted that you've joined us for the second webinar in our Clean Energy Back to Work series. We've got a terrific program today and some great stories to dig into. But before I introduce our superstar panel, I wanted to tell a story behind the Clean Energy Back to Work Challenge. So clean energy is obviously a key to economic recovery in the Northeast and across the country. But getting back to work has presented many challenges that have needed both innovative technology and human resource management skills. NECC's Clean Energy Back to Work Challenge is a new initiative designed to highlight clean energy organizations that have successfully adapted their business practices amidst the ongoing COVID-19 crisis. Since the outbreak of the pandemic, the clean energy industry has lost more than 620,000 jobs across the country. The Back to Work Challenge is intended to demonstrate new approaches that can enable a reversal of course as businesses carefully get back to work. To that end, we at NECC invite you to submit your best practices, pilots, and innovations to address the challenges presented by COVID-19. The Back to Work Challenge will culminate on November 12th with a new virtual awards ceremony that showcases submissions from the industry. Nominations are due on October the 1st, and that's a new deadline date that was pushed back a bit. 5 o'clock on October the 1st. And then we have 5 award categories. The Customer Acquisition Award, the one we're going to talk about today, the Innovating Remote Work and Technology Solutions Award, the On-Premises Project Construction and Installation Award, the Greenhouse Gas Reduction and Public Health Mitigation Award, and the one we heard about a couple of weeks ago, Community Engagement During the Pandemic Crisis Award. And all of that's available online on our website. Now, if we could move on to the next slide, I think. We would not be able to do this without terrific sponsors. So first, I would like to thank our colleagues at Schneider Electric, who are great partners in NECC's work and members of our strategic partner network, but who've also stepped up to sponsor this webinar and this award series and to sponsor the Innovating Remote Work and Technology Solutions Award. And you'll be hearing from several people from Schneider Electric in a second. Next slide, please. We're grateful to all of our sponsors, and you can see the list here, who've risen up and helped us with this Back to Work Challenge. And we want to acknowledge their strong support and partnership. You can see the list there. And finally, we're grateful to you, our community, for your engagement and enthusiasm for the clean energy transition. Thank you all for joining us today. We can move to the agenda slide, please. So we've got a terrific program today, anchored by an all-star cast. In a moment, I'll ask Kevin Self, SVP at Schneider Electric, to set the stage for our discussion, but I wanted to go over a few logistics before introducing our speakers. We are going to try to put an emphasis on an interactive discussion among the speakers, so we'll have time for Q&A at the end. I'll be looking in the Q&A box, and we'll have a slide up to show you the instructions later on, but please get your questions ready and have them ready for the Q&A starting about 20 minutes before the end. So we look at the agenda. Kevin Self will talk about Schneider's commitment to reducing Schneider's physical footprint before COVID-19 as part of its decarbonization strategy and how that prepared them well for dealing with COVID-19. And then Mark Fiesel will talk about how some of their technology can help shape a greener post-pandemic world. And finally, Lance Haynes will tell us about how he and his team were able to overcome travel restrictions and how they commissioned a microgrid remotely. And with that, I think it's my pleasure to introduce Kevin Self, who is the Senior Vice President for Strategy, Business Development, and Government Relations at Schneider Electric, and he will then introduce the rest of the panel. Thank you very much, and over to you, Kevin.
Very good, Alistair. Thanks much for having me and Schneider Electric today. To Alistair's point, I'm Kevin Self. I lead Strategy and Government Affairs for Schneider Electric's North America business. Next slide. And so what we want to talk about is, to Alistair's point, first, what Schneider Electric is doing in this current COVID-19 world, and even as we look to the post COVID-19 world, and what are the steps we're taking in both in the US and across the planet. Next page. You can jump to the next. Thanks. So Schneider Electric. So this is our moniker, right? We empower all to make the most of their energy and resources, ensuring that life is on everywhere for everyone at every moment. And also we believe that the way that energy is currently being delivered on this planet is not sustainable, and everyone on this planet has a basic human right towards energy. It's sort of what we're chasing continually, led by our CEO, Jean-Pascal Tricoire. Next page. So to give you a bit of an overview on Schneider Electric, we're actually 184 years old. Very few companies make it this long, so obviously during that time, we've made a number of pivots. And you could argue we're in the midst of one now as the world is becoming more electric and more digital. And so we're about 27 billion euros. We spend about 5% of that for R&D, both internal R&D that we do ourselves, as well as we have a venture arm named Schneider Ventures, which does a lot of work on the fringe. We call it innovation at the edge, identifying new technologies, new opportunities that we think we have a right to be engaged with. And so we work very closely with that group. As you can see as well, as it's a well-balanced global presence, about 25% of the business in the four corners of the world. About 77% is on energy management and about 23% on industrial automation. The other interesting thing is, when the world became less, or when we all sort of locked down earlier this year, working remotely is something that Schneider had really been doing for many years. We have a very distributed leadership team. Even though we're based in Paris, our CEO actually sits in Hong Kong, which is where he's been for the last 8 years. Our CFO sits in Paris. Our various business leaders really sit around the world. And the US is no different. I actually work out of southeastern Wisconsin. Our US country president is out of Chicago, and Mark and Lance are also regionally located across the US. And so the whole global, or the footprint, is something we had started addressing. We had originally identified how can we reduce our footprint by 10% this year. Then COVID hit, and we're actively looking now to work to really reduce it 30%. As we, and maybe many of you have found, is the ability to stay connected with these digital platforms in most cases is actually working better than what we had anticipated. And so we see a continuation of the world being quite remote for a period of time. Next page. And you can do the build. The other thing that we're very focused on is this climate emergency that we're living through right now. We actually are partners with the Global Footprint Network, and every year putting out some information on Earth Overshoot Day. And the definition of Earth Overshoot Day is it's the day when humanity's demand on nature exceeds what the Earth's ecosystems can renew in a year. So in a perfectly balanced year, it would occur December 31st. But obviously the planet's not perfect. And so this year, that date was August 22. So on August 22nd, a month ago, we had already used all the resources that this planet can produce on an annual basis. So therefore, we're using too much. The good news is it was delayed about a month from the previous year when it was mid-July in 2019. And obviously that's driven by the slowdown of the world economy because of COVID. Obviously not sustainable. This chart here that you look at, 80% of emissions are due to energy consumption. So we have to fix that going forward. And the energy consumption is multiplied by 10 in the last century. And if we don't do anything, it's going to be 4 times more in this century. And then lastly, this is in a world where 60% of the way we manage energy is already inefficient. So this presents opportunities. And what companies like ours love to do is jump on these problems and help to solve them. Next page. And so just in closing on my statements, we believe life is on when it is both powered and it is digital. And so as you can see on the left, what we're happy, and Mark Fiesel will be talking about this as we'll Lance in a couple moments, is the growth in renewables in the US and on this planet. the number of vehicles moving towards electric. We keep hearing these stories every day. We're engaged in many conversations across the US on fleets really moving towards digitization, in a lot of cases driven by carbon neutrality commitments. And then to the right-hand side of the page, what's really driving this is the ability to connect. And so all these devices we have that we're able to monitor, it gives us better information to really manage these energy assets, which we feel is incredibly important for us to be successful going forward. And now to get into more of the details, I hand it over to my colleague, Mark Fiesel.
Thank you, Kevin. Next slide, please. Thank you. So Kevin talked a lot about the trend of digitization, and quite frankly, it's having a profound impact on the energy system as we know it. I know I've got a lot of energy veterans here on the phone and some colleagues and friends from the past, so I appreciate you guys joining. And I'm sure I learned some of this from each of you on the call. But we've profoundly seeing really though is data decommoditizing energy. Energy, electricity specifically, is this invisible, dangerous thing that travels at the speed of light. But when we can begin to characterize it with data, we can begin to break electricity down into its more fundamental elements. How resilient is this electron or unit of energy? How sustainable is it? And what's its cost? And what are the drivers of those costs? And how can I get more predictable costs? We found that once consumers have that kind of insight, you essentially create situational awareness. And when someone has situational awareness, they can begin to be empowered to operate differently, to interact with the grid in new ways. And in doing so, solve for energy that is aligned to their specific business objectives. We know that from a utility, we may get the same type of electron or nature of an electron that everybody else in the same feeder or circuit gets. But my goals may be different than everyone else's. I may have a different sustainability goal. I may have more or less risk around energy price, and an outage may have a more profound impact on my operations than other people. So leveraging data and acting upon it is how a consumer becomes a prosumer, interfacing with the grid in a new way. Next slide, please. Interesting questions. What's critical infrastructure? I think that I may have answered this differently just 1 year ago than maybe I would answer it today. We live in a world that is increasingly connected digitally. So we've managed to connect nearly everything over the cloud, and the impact of an outage is quite a bit different than in the past. Thinking about the public safety shutoffs that occurred last year in California as a result of the wildfires, we learned a lot of things. One thing, for example, was that those outages resulted in taking down some of the communication networks. And in the past 5 or 10 years ago, our emergency responders would have had hard paper maps in their vehicles. Well, guess what? A lot of them didn't, right? They're operating off Waze and Google Maps, just like I am when I'm driving. They may have had, paper logs and other information about the assets that they were inspecting. Guess what? They didn't necessarily have that anymore. They were using cloud-based asset management systems to log what was broken and what was not. So we found that the interdependency between the communication system and that outage was a little different than we thought about in the past. When we thought about resilience 5 years ago, it was the things you see on the left. It's your hospital, it's your water, wastewater, data centers, military bases. But I think about, here in the midst of COVID, in some of at least the early guidance, I live here in Ohio, that we were getting was that we didn't, we had completely stopped doing elective surgeries in our hospitals. If at all possible, we weren't supposed to travel to the hospitals. We were supposed to get services at clinics. And so you think about some of the procedures that got moved out of the hospital and other places. Well, a hospital is designed, when an outage occurs, to respond to that, to be able to provide secure power to critical circuits, to ensure telemetry stays online that's critical to healthcare. Those smaller, less intensive facilities like a medical clinic don't have that same kind of backup system, nor could they possibly. It would be impossible to transfer the heavy infrastructure that goes into a hospital to the medical clinic that is, installed in a mall that went out of business or something like that, right? So we got to think about those in new ways. We also thought about and saw impact of other interdependencies. So grocery stores, food distribution warehouses, still to this day, I'm seeing, outages of certain kinds of food within my grocery store. And some of that was linked to supply chain issues. The supply chain wasn't hardened to the extent that it could deal with this uncertainty of employees coming into work. Certainly a power outage or other kind of things could have an impact upon those facilities. So, we're just increasingly seeing a different type of asset that needs hardened. So we're going from a scenario where very few things need hardened to a scenario when many, many more things need hardened. So let's talk about what some implications that are. So next slide, please. So when we're installing and hardening that critical infrastructure that was on the left, those tend to be larger, energy-intense campuses. They, in many cases, staff teams of engineers that are capable of assessing what are the technical aspects of this solution, what kind of generation should I use to back up my hospital, what are the interconnection rules. They understood very well maybe the regulatory constraints. Can I interconnect this with the utility? What kind of protection do I need? And they understand some of the financial risks as well. What's it going to cost me to build this? They had a maintenance staff. Think about those new kinds of facilities, though. Everything I just, talked about, this large staff of technical people and regulatory understanding and deep insight around energy procurement and operations doesn't exist to the same extent in this less energy intense infrastructure. So next slide, please. So we really have to think about abstracting complexity. We can't get rid of all risks. If you are going to harden a new type of infrastructure, you still need to do many of the same things. You need to be able to predict energy load to ensure that you've got enough capacity to supply it. You've got to understand what loads are critical and what aren't critical. You've got to be able to understand what the weather is going to be and how it's going to impact my consumption and what the irradiance is going to be and how it might impact the output of my solar. So, those are sophisticated things. And, clearly 5 years ago, we would do those kinds of things in that larger environment. But to do it is costly to install, costly to commission, and costly to maintain. When we think about that lighter infrastructure, it simply can't bear those costs. So we've really thought about this idea of abstracting complexity other places. So one specific place is to the cloud. When we move complexity to the cloud, we can put a much larger computing power on it. We can solve to even a more sophisticated level, improve predictions, improve operations of the system, all while spreading those costs across many more people. What you end up with is something that is much more simple on site that can be installed much more easily. The second place we think about abstracting complexity is to the factory. So with advanced manufacturing, we have been able to move many of those things that we would do at site into the factory environment with all the quality controls and training and documentation that go into that factory environment. That allows you to deploy microgrids that are much more modular, much more scalable. Lance, who is going to be speaking right after me, is going to talk about scenarios in which we've simplified it to the point where these microgrids can be installed, commissioned with very, very low touch on site, especially important in times like COVID. The third area that we think about abstracting complexity is via business model, and that is the story of energy as a service. And next slide, please. Energy as a service is really the story of bringing the benefits of a microgrid to an energy consumer without asking them to take on all of those regulatory and financial complexities. The specific example here is Fifth Season. Fifth Season is an indoor agriculture energy consumer, and by the way, once again, a type of load that we would consider critical now that maybe we didn't. When we think about people urbanizing, we think about transportation potentially getting disrupted in times of COVID due to illness or other reasons. Being able to create food very close to where it's consumed is a form of resilience, and so protecting the energy supply to that can be very important. But as you can imagine, Indoor agriculture isn't the kind of place where you're going to find a team of engineers that are, and a whole bunch of lawyers that are able to go and figure out technical solutions and connect those with the grid. Instead, these facilities simply need to understand how they can get the kind of power that's important to them. Is it as green as they desire, which is often very important in the indoor agriculture space. You may know that indoor agriculture generally uses no pesticides and 95% less water, and the people that desire their goods also care about sustainability. And so we see indoor ag striving to have very sustainable energy. Resilience is also very important. These plants and other things can be damaged with absence of heat or absence of light. So it's very important that we keep those on. And of course, energy cost, extremely important. After labor, it's the highest cost associated with operating these things. And so when we can bring energy as a service, essentially create an easy button for indoor ag in this case this season to get sustainable, resilience, predictable cost energy, we're beginning to serve this entire market in a new way. And I'm going to turn over to Lance now to take some of these more business concepts and let's get technical and see what we're looking at.
Thank you, Mark. I appreciate that. So I'm going to go ahead and talk about one specific example here. We're hearing all over the world these stories of innovation as a way that we humans are able to fight back against this teeny little virus, very nasty virus, but I think innovation is the key way that we're going to get through this and potentially even have some nice silver linings for afterwards. So in this particular example, there are just three things I want to hit real quick. One is the intended microgrid operation, just so you're clear what we were trying to do. And then I want to talk about what the key enablers were that enabled us to overcome COVID on this project, and then wrap it up with result and conclusion. So excuse me. So what you see on the screen is an energy control center, and also proof that I'm not the world's best photographer, as I slightly clipped the side of it there. Sorry about that. I'll be referring to that as an ECC elsewhere in this presentation. Next slide, please. So let's start by walking through a day in the life of this microgrid while the grid is up, just to sort of establish how things normally work. So, in the night or the wee hours of the morning, we'd find power coming in from the utility, and some of that going to the critical and essential loads, and a bit more of it going to standard loads. Then moving on to the morning, we would see that the solar inverters start to contribute a bit of power. We'd also notice that the standard loads start to require more power as the workday begins. And so the amount of power from the utility decreases a bit, but it's offset by the increase in load. And so we see that our various loads here are sort of being fed by a mix of the utility power and the renewable energy generated on site. Then moving on to midday, we see this is where the solar power really gets to cranking, and we're able to provide more power than the loads need at this particular site. And so we are storing that excess renewable energy locally in a lithium-ion battery energy storage system right on site. And so as we move on into the evening, we'll notice that now the sun is set and the solar is no longer contributing. So we again get in this situation where we're mixing utility power and that renewable energy that we had captured earlier from the solar and stored in the battery. We're now letting that back out after sunset and having a combination of renewable and grid electricity for the loads in this scenario. So that's a day in the life while the grid is up, but things are going to get a fair amount different if the grid goes down. So we'll walk through a day of that. So here with the grid outage, one thing to notice right away is over on the left-hand side, inside the dotted green line representing the ECC, the main breaker is open. And that's how we are able to isolate the site's electrical system from a grid that is down, is the microgrid control system automatically opens that breaker to begin the islanding. And you'll maybe also notice that the breaker for the standard loads is open, and we use our precious nighttime energy from the battery to power just the critical and essential loads at first. But then moving on to the morning, we see that as the sun starts to come up, we have not only enough power for those critical and essential loads, but we have the ability to start recharging the battery a bit. And then again, moving on to midday, we now have a sufficient amount of power that we can go ahead and close back in another breaker if there's sufficient sunshine that day, and power more loads while we're simultaneously still capturing excess power to recharge the battery. And we can do this maybe for several hours, kind of in the peak hours of the day, but then as we get to moving on to the late afternoon, we notice that the amount of power from the solar is decreasing, so we actually need the battery energy storage system to kick in if we're going to try to keep those standard loads up for a while. And then eventually we move on to the evening when the sun has set, and with no contribution from the solar power, we need to really preserve that energy carefully. And so we go ahead and stop providing power to the standard loads and save the battery energy for just the critical and essential loads. So I just gave this quick overview to illustrate that there's a couple of different sequences of operations, as we call them, that the system needs to go through. And this is just part of bringing up and validating during the commissioning stage of a microgrid that everything's working as intended. And normally the way this is done is after all the equipment is installed, all the subsystems have been verified, a Schneider engineer hops on a plane or hops in his or her car and goes to the site. And the final step of all this is the commissioning, where we check out that the microgrid control system is doing everything just right. If we run into a snag here or there, we do a little troubleshooting. And that's the normal way we do it. And this is where coronavirus really threw a wrinkle at us here. Next slide, please. So as COVID hit on this particular project, we were very close to the finish line. All the gear was installed, all the subsystems were commissioned, and literally the phone was ringing from our partner saying, okay, can we get your engineer scheduled to come on out and finish this up? And just as that conversation started about when would be the optimal time to come on out, COVID hit, and we really understood that we were in a whole new situation. So as you know, there were travel bans in many places, and in particular, the state where this microgrid was had a 2-week quarantine period. So had we just decided to ask our engineer to hop on a plane and travel to the site, they would have had to spend 2 weeks locked in a hotel room before they could come out and spend a couple days at the site commissioning this microgrid. Certainly that's a big wrinkle. There was no budget for an extra 2 weeks of travel cost on top of a couple days of work, as one could imagine. So as we look to overcome these challenges, 3 key enablers that I'm going to go through. First and foremost, we had a fantastic partner on this project, and they already had personnel going to the site on a daily basis. They were not subject to the 2-week quarantine because they were already in state. We have a very strong history of working with this partner. And so we offered as a coronavirus-driven innovation to reach into our 2021 roadmap and some things we were planning on trying in 2021 around remote commissioning. We decided to try those on a trial basis for this project in order to get it across the finish line. And so our partner agreed to undertake this innovation with us, and I really commend them for that and enjoyed going through this adventure with them. A couple other key things that we'll elaborate on in the future slides is the cyber secure connection that was necessary, and also how we practiced to do this, since we were doing it for the first time about a year ahead of schedule. Next slide, please. So when we look at our standard approach to commissioning an ECC-based microgrid, as I mentioned, the Schneider engineer gets to the site and they take their Schneider laptop and they take an Ethernet cable and plug it into the Ethernet switch inside the left-hand section of the ECC. And that allows them to methodically, go through step by step, make sure, communications are good between all the subsystems, make sure responses are as appropriate, and check things out methodically, troubleshoot if necessary, and just make sure the whole sequence of operations is going to operate as intended. So since we couldn't have our engineer hop on a plane, we had to figure out another way to do this. And so next slide, please. We basically decided to use the internet as a very long Ethernet cable. So our engineer stayed in his home office in North Carolina and connected out through the internet and through a remote VPN on the site. And so this was that second key enabler. This is a little box about the size of a lunchbox, and we were able to ship that to the site. And the local IT department was willing to provide a outgoing HTTPS connection, a port 443 connection for the techies in the crowd. And only by having that outgoing secure connection, it is, that's the essence of the cybersecurity is you can only make outgoing calls with this little box. And then on the local area network side of the little box, we plug that into the ECC just like the Schneider laptop would have been connected. And so altogether, the technology works to provide with a pretty modest amount of latency, a connection from the Schneider laptop in North Carolina to the ECC-based microgrid at the site. So that was a key thing. But as I mentioned, we hadn't done this before, and indeed this was on our roadmap for 2021. So we really were concerned about making this go as smoothly as possible, especially because for this first time, we expected our partner to have a person on site during all this to be the eyes and ears that our engineer was not able to use his own eyes and ears for. And so we decided that practice makes perfect. And if you could go ahead and go to the next slide, I'll show you how we did that practicing. So the engineer stayed in his home office in North Carolina. We shipped the little box to an office here in Boston, specifically mine. And in my home office, I had the remote VPN, a real microgrid controller, a real touchscreen HMI and Ethernet switch, but the whole rest of the microgrid was simulated. So on a Windows PC, we had a Schneider ECC microgrid simulator running, along with a port address translator that allowed us to simulate many different assets on many different IP addresses. And so with roughly half a dozen practice sessions, ranging from an hour or two to a half day, we really kind of worked through this and had our A game ready by the time it was time to do this for real. So next slide, please. So, the end result was we ended up successfully commissioning this microgrid with our engineer never leaving North Carolina, and the comparable, number of hours on site for our partner. So rather than the two of them standing side by side on site, one of them was standing on site and the other was in North Carolina. And it was a very successful outcome in terms of benchmarking versus regular commissionings where they would have been, side by side. And we're very, very optimistic about this going forward. And so we are looking to continue developing and maturing this methodology. And we believe this is going to lead to further operational efficiency increases in the future that will help us as we deploy microgrids and work to bring that resilience and sustainability more and more broadly, as Mark and Kevin were alluding to earlier. So that's the end of my specific example. Thank you.
That's great, Lars. Thank you for that. Really interesting example, really creative, and really helping the customers through a pretty tough time. So very impressive. So now I'm going to ask a few questions of the panel, and I'm hoping that the audience is lining up your questions. You can see here on this slide how you can log a question in the Q&A box, which I can read. And what I'll do is read those out and ask the panel to respond. But first, just so please fire away and start putting questions in there. And while you're doing that, I have a question for Lance. Very impressive innovation you did there, but is it all proprietary stuff, or is that technology that you can share with others? So I think that's a good question for you, Lance.
There's a mix of both. So inside Schneider's microgrid control system, we've got a lot of proprietary technology that we've invested quite a bit in developing. So a lot of the technology inside that ECC is our proprietary technology. However, the little box, the remote VPN that I showed, was off-the-shelf technology. So that was a device that we were able to purchase for less than $1,000, and believe that we'll be using regularly going forwards.
Excellent. And what's providing the cybersecurity? You said there's a strong cybersecurity sort of protection in that. Is that little box, or is it something else?
Yeah, it's the fact that that little box is only cleared to make outgoing port 443 HTTPS calls. So the network really didn't have to expose itself to anything other than opening up one outgoing port.
Okay, great. And then you talked about a partner. So you said that they're your partner on site. They've got a long relationship with the customer. But can you kind of explain a bit more about the profile of that partner?
Well, I think in particular for this webinar, it's very relevant. The skill set of that partner for making this all work out. So the sort of core skill sets are, the renewable energy expertise and the power systems familiarity. So, these would be skill sets one would find in, licensed electricians, in solar installers. So that would be a lot of kind of the core skill set. And what we did as preparatory activities is a bit of that, IoT or networking skill set. Our partner was willing to invest a little bit of their own time to kind of get to be a bit of not a network engineer, but sort of like a network technician. And so they kind of got familiar with some things so that if we talked about changing a subnet or ping this or ping that, that they knew exactly what we were talking about and didn't have to say, what's a ping or what's a subnet?
Okay, so sort of follow-up question to that. It sounds from what Mark said, you're trying to make microgrids simpler. You're trying to make the whole process much easier. So I can imagine there's going to be more interest. So are you going to be looking for more partners like that partner in Hawaii in the future? And I don't know if that's a question for Lance or Mark. But
I can kick that off. So yeah, partnership is a very key element of our approach going forward. So we see a world in which we will be deploying technology that's increasingly scalable and increasingly modular, and that's our strength, right? Kevin talked about who Schneider Electric is. We're a energy IoT company, and we know that people that can give us geographic proximity and agility to our customers if we can create some lasting partnerships. So it's a big focus. Some of the key elements. We're still in an early market, so partners that have some relationships with energy consumers. Maybe it's a place you've done some great work in the past. We'd love to talk to you about it, collaborate, help you build your skill set, provide you with some tools that could help you take some of this technology to market, help you differentiate from your competitors potentially in your area, and together go be successful in building this market out. So we'll definitely on the lookout for partners.
Excellent. And if anyone is interested in being a partner of Schneider for this activity or anything else, who should they contact?
Yeah, we have there's some resources available online. So under the Schneider Electric Microgrid web pages. You'll find information about more precisely about the kind of things that we're doing. And if you get, if you see some things there that make sense, it would be, reach out to me. I have a person on my team named Don Wingate. So if you already know Don, you could reach out directly to Don. But Don leads our partner relationships.
Okay. And maybe you could put that in the chat, Mark. That would be helpful.
Sure. Yeah.
That's great. Yeah. Well, I'm sure there's going to be some interest there. And then thinking, this was one great innovation which you brought forward from your roadmap. So I guess it's not the only thing on your roadmap, Lance, and it's not often we get to talk to a CTO. So have you got anything else up your sleeve that you think might come out next year to help advance the adoption of microgrids like this?
We definitely do. It's a little bit early for me to say too much about it, but I'll give a little bit of a teaser. We will fairly soon be announcing a new web-based collaboration platform for microgrids that I think will be another quantum leap forward in terms of simplifying microgrids and allowing partners and Schneider to work together and scale these solutions much more broadly.
Okay.
And I'll also add, we just announced last week, in fact, a new company that we have stood up. And so we have been doing energy as a service now for many years. You can find a bunch of our case studies out there. But a challenge with energy as a service is how to scale it down. And one of the things I talked about during our conversation today was we need to be able to scale down to less energy intense facilities. There's only so many JFK Terminal 1s and Miramar, Marine Corps Air Station projects that you're going to do a year, and you're going to have a lot more smaller projects, and we recognize that. So we've been working very hard over the last year and a half to put together a business model in which we could bring together the right kind of contractual legal framework, the right kind of investment partners, and we just completed that. So launching last week, new energy as a service aimed at 500 kW to about 5 megawatts. And you're going to find that's about 90% of all commercial industrial load in North America. So we're going to be able to hit a lot of the sweet spot. Brand new, didn't have it 2 weeks ago.
One other addition I'd mentioned earlier about our Schneider Ventures team looking to invest in innovation at the edge, and probably I think earlier this summer we invested in a company called Station A, stationa.com, that has one of the strongest, from what we've seen, abilities to understand what the opportunities are on a building by building basis. And so I'd recommend you take a look at them as well.
Station A. Okay, thank you. I've
Station
definitely
A.
heard of them. Yeah. Weren't they part of NRG at one point?
Very good.
Yeah, know some people there. Yeah.
Actually, Station A, I believe, is the name of the first power plant, maybe only power plant in San Francisco itself.
Okay. Right, that's the origin. So we do have a question from one member of the audience, which I want to share with you now because it's kind of relevant to the last bit of the conversation, which talking about partnerships. You're a big company. You've got lots of experience of finding partners, recruiting them, managing them. But if you're a small company without a worldwide footprint, but you've got some good solution, do you have any recommendations for how you create relationships with companies who've got boots on the ground at a site like your example, far away?
Yeah, I think a key way to get, attention is, if you're a company with boots on the ground and you've got a great relationship with maybe a facility you've been doing work with. I worked for a small company in Lima, Ohio for about 10 years. And I know that we had, great relationships with, some local companies, and someone that has those kind of relationships and can help us get to, can help localize us in some way. That's a great benefit. We see that's a great benefit. And in doing so, we get to know you a lot better. We can talk about our relative strengths and weaknesses and how we can work together to complement one another. So we're very open to that.
Okay, well, hopefully that was a good answer for you, Maura Applebury. Thanks for the question. So I'm looking out for more questions. I don't see any, so I'll go on with mine. So NECC covers innovation, covers partnerships. We've asked questions about that, but we also cover policy. So In thinking about this example, Lance, did you have to have any local sort of permitting or approvals or policies altered so that you could go ahead and commission the microgrid remotely?
No, we didn't.
Okay, that's good to hear. But you think you might encounter that in other geographies?
Yeah, it's always possible.
Yeah, I can add a little bit there too. So something we have been working on, we worked a lot on was this BRIC, recent federal legislation around BRIC funding. And who can help me remember what that stood for? Something resilience, anybody else?
Resilient infrastructure.
Yes. Yeah,
Okay.
you're closer than I, Alistair. But you know, this was something that communities have difficulty mobilizing for an event before it happens. You know, unfortunately, we tend to live in a society that manages by catastrophe. Something bad happens and all kind of fun show up, but it's always, you know, hectic and very hard to get the right things done. And I applaud the work that's been done to make some money available to communities that ahead of time to begin this kind of planning, to put some investment of resilience in place. And so I think that's going to help. And, you know, I would encourage, you know, states and other local communities to consider that. We're getting better and better about valuing resilience. This is something that can always be a little bit hard to get your arms around a little bit. Everybody knows what an outage costs them the moment it happens, because they had to send the shift to people home, or they had to, you know, a whole bunch of food in the freezers. If you've got a refrigerated warehouse failed, or your steel furnace rocked up because the steel cooled down, people can figure out those costs at that point. But you get removed from that 6 or 8 months, and it's kind of hard. And so there's been some good effort there. I know an effort that we've specifically supported recently is the continued evolution of the PEER standard by the U.S. Green Buildings Coalition. So of course, USGBC was instrumental in LEED. LEED's had a pretty profound impact on improving the efficiency and sustainability of our building footprint. And at the same time, LEED has demonstrably improved the value of assets for building owners, because there's companies like Schneider Electric who only rent space from a LEED certified building. At the same time, resilience wasn't factored very, very well into that. It was only touched upon but not factored in. PEER represents a mechanism by which the USGBC is really putting some hard grading mechanisms around resilience. And I think that, you know, supporting that standard, encompassing it in the projects, and we think about it, will be an important part of creating value.
So let's spread the word. Okay, that's good. So we've talked a lot about microgrids, but I know you started off, Kevin, by talking about what you've done in your own building. So have you had other property owners, companies come to you and say, hey, I've heard about what you've done and how you've organized yourselves, and given them tours to see if they could take best practices away from you and deploy them themselves?
Yeah, we have sort of, actually Mark and I were on a call early this morning where we were highlighting some of those around the world. But look at, to Mark's point earlier about us wanting to work with partners, we're very open to have, you know, people come and tour our facilities and sort of see firsthand what we've been able to put in place. Obviously, once you can tour places again, and even I think Lance had mentioned our Andover, Massachusetts facility, which we had put a microgrid in there, gosh, probably 4 years ago or so. Now we see it as a showcase where we're able to highlight the capabilities in one spot. So no, we're very open to show people what we've done. And actually something coming up later this week, it'll be announced, but we have a manufacturing facility in Lexington, Kentucky, that's I think 63 years old now. So a 63-year-old senior citizen facility that we have made one of the most productive within our fleet of facilities. Increased optimization, reduced paper, a year-over-year energy savings of 3.5%, and we're going to receive a pretty major award this week, and we're going to be highlighting it. We'll have a video out on it, but so you'll be able to virtually tour it. But the capabilities we're talking about providing is both within, you know, the commercial space, obviously the residential space we haven't talked about much, but also the industrial space.
So resilience is one part of it, but just having an environment that you can work safely in is part of the new requirement. So have you done anything in that space, in that arena?
In the which space, Alistair?
Creating a healthy environment, right? So, you know, I think with COVID,
Yeah,
use of energy is important, having resilience is important, but now you've got to have, you know, an efficient way to deliver clean air, you know, a productive environment. So
yeah, we're actively working on many different examples for that. I mean, one thing we have done, it was announced earlier this summer, is a partnership with LAX Airport on more not on the air as much, but on thermal imaging. And so as airports, right, try to convince the population that, you know, walking through our facility is a safe endeavor, how are you going to convince the population? And so we're doing some work with LAX at the moment.
that's great. Okay, thanks, Kevin. I'm just seeing lots of activity on the chat here. So Mark's been very kind and putting stuff in the chat to answer people's questions, so that's helpful, but no more questions. But I think we're sort of getting to the point where it would be good to wrap up and ask, I'd like to ask each of you if you have any sort of final comments that you want to share with the audience as we wrap up this conversation. So Kevin, maybe if I can ask you to start.
No, so, you know, harkening on what I brought up, you know, we're a 184-year-old company that's made, you know, changes to survive 184 years, and this is but another one. I mean, what we're all experiencing right now, unless some of the people on this webinar were here in 1917 or 1918, we've not been through this. And so, you know, the decisions we make about how to move forward are very real to us. And what Mark and Lance spoke about in terms of the world becoming, energy becoming much more decarbonized, digitized, and decentralized is going to continue, is only going to continue faster. So we would push everyone to get on board and help us move this forward. And success will be you know, in the coming years, is that the Earth Overshoot Day will continue moving back a month every year until it finally rests on December 31st.
Good thing to aim at. Yeah, thank you, Kevin. All right, Mark.
And I would just say, you know, I think investing in situational awareness with respect to energy is a no regret decision. We're learning this now. I don't think any of us really understood what would happen to the grid when, you know, going into this scenario where people working from home and not at factories, and there have been some interesting challenges, and, you know, with respect to load growth or overload in some cases and underload in other places. But having situational awareness to this and being able to understand what's happening in real time and not having to wait for a month or two for a bill to get there can be critical in you know, conserving and preserving your balance sheet and solving for the needs of your business. So that's, you know, been a key focus. And I believe something that we're learning through all this, that the power of digitization, data, and the ability to act quickly and with agility is extremely important.
Great, thank you, Mark. And finally, Lance.
Okay. I would say, I imagine there's a fair amount of people on today's call that would be really excited about a end state some years in the future where we had 100% renewable power. And there are some big technical challenges if we're going to get there. But I think what we're seeing is how, you know, microgrids and that situational awareness that Mark was just referring to are some really key parts of that. And so as we deploy microgrids at scale, I think we're deploying technology that's really going to be a key part of enabling a march towards a someday 100% renewable grid. And you know, there are a lot of challenges to solve. The last couple miles of that journey will be by far the hardest, but I believe we can get there eventually. And what's really key out of this coronavirus thing is across the board, you know, from microgrids to schools, we're finding out that we can do so much more with digital technology than we ever realized we could. And it's like the old adage, you know, necessity is the mother of invention, right? So sometimes you figure out how to do things because you just have to. And I think, with our response to coronavirus and not just Schneider's, but humanity's response to coronavirus as we get smarter about things, and if we keep innovating and thinking forward, we can also solve the various challenges that are between us and a 100% renewable grid someday.
That's great. That's very inspiring. And I really applaud the Schneider team for rising to the challenge that has been presented to us this year. And, you've talked a lot about Microgrids specifically, but was impressed also last week when you did the presentation with Greentown Labs, another of our partners, around the bold ideas for energy storage. So we look forward to more innovations coming out of that process too. So it's good to see all the different things you're doing in the Northeast. So with that, what I'd like to do is ask our audience to give our speakers a virtual round of applause. I know that you can't hear them, but maybe they can send applause messages up on the screen. But it really was an inspiring collection of stories, just demonstrating some of the really innovative and creative things that Schneider can do, but really demonstrating how you've responded to this challenge and showing great leadership in doing that. And I think willing to share that with our community and wider. So really appreciate that. I wanted to thank our audience for joining us. And now I think it'd be good to go to the next slide. There's a few upcoming events we've got from NECC, a couple of key dates. Next week, we have a webinar all about opportunities for hydrogen in the Northeast. I think, Lance, you talked about how, if we want to go full renewable, we're going to need a good mix of technology. And we're seeing around the world that hydrogen is filling that gap in some places, or there's great hope for it to do so. So we want to explore what some of our members are learning from around the world and what's going on. So we got a great cast of speakers for that one. And you'll see registration links for that on our events page, or you might have seen a newsletter. Then coming up, one of our flagship events on October 1st, the Cleantech Open Accelerator in the Northeast has its regional finals, which is always a great event to see the latest startups coming out of the woodwork. We've got a large number of them this year because we ran the whole program remotely. So it's a public event. Always good to see. I think you'll get to see 6 or 8 of the finalists pitching on the night. And then we've got, as I said before, the culmination of the Clean Energy Back to Work Challenge. We have a big event on November 12th, and we're going to start marketing that soon with more details of exactly what that will look like. I just asked you to block your calendars for that. And so I think that's it. Is there another slide? Yeah, just to say a final thank you. So thank you, Kevin, Mark, and Lance. Thank you, Schneider Electric. Thank you for both being here today and sharing everything with us, but also for sponsoring the Back to Work Challenge. And we look forward to continuing working with you on this and other discussions as part of our of the Back to Work Challenge. I hope you'll be there on the night of or on the afternoon of November 12th. So thanks again and farewell.
Thank you. Bye now.
Bye, everyone.